All right, here are the solutions. Best of luck. Right, so this is a question very similar to the task we did in class about the woman that saved $150, I think it was, every year or something like that, $100 maybe, for like 50 years or something, and ended up with $500,000. Similar idea here. So for part A, what we want to think about is that each year you're going to save this $500, and this $500 that you save each year is going to sit in the bank for the remainder of the 20 years, and each year it's going to get 4% interest. So if you think about the first $500 that you input, after the first year you're going to accrue 4% interest. So you're going to multiply 500 by 1.04. And each year you're going to multiply by another 1.04 to compound the interest. And so by the time you're done, that first $500 is going to be 500 times 1.04 to the 20. But don't forget that at the end of year one, you're going to input another $500, and that's going to sit in the bank for 19 years. So by the time you're all done, that'll be 500 times 1.04 to the 19. And you're going to continue inputting this $500 into your bank every year until the very last year when you're going to put in $500, but that's at the end of the 20 years, so it's never going to get any interest. And that's going to account for all of the money that you have in your savings account. So to find out how much you'll have after 20 years, you're going to need to add up the value of the 500 that's been in for 20, the 500 that's been in for 19 years, and the 500 that's been in for all the years going down until the 500 that's not getting any interest. It just was put in at the very end. And so what is this? Well, if you think about each of these terms, these are the terms of a sequence where my initial value is 500 and my common ratio is 1.04. I'm multiplying by 1.04 each time to get to the next term. And so when I add these all up, I'm taking the partial sum of 21 terms, right? This is the first term, second term, third term. And remember, this is like saying 1.04 to the 0th power. So 0, 1, all the way up till 20, that's the 21st term. And so you're taking S sub 21, the partial sum, where my initial value is 500. The common ratio is 1.04, so I raise it to the 21st power and subtract 1, divided by 1.04 minus 1, which is $15,984.60 after 20 years. And you might think, does that make sense? So pause the video, and if you haven't already, think about whether that makes sense. The reason it makes sense is, imagine that you didn't accrue interest at all. You just saved 500 every year for 20 years. Well, in the very beginning, you have 500, right? Another 500, another 500, all the way up to the very last 500. How much would you have? Well, if you think about it, that's 21 500s. Well, 21 500s is going to be $10,500. But you should have more than that because you're getting 4% interest each year. 4% isn't a ton of money though, right? 4%, it's not huge. I mean, 4% of 500 is a decent amount if you think about it, right? 4% of 100 is 4, so 4% of 500 is going to be 20, and so you're gaining, $20 per year for each 500 investment, and that's going to give you about 5,000 extra dollars, and so that's not bad at all, and certainly you'll take that, right? You won't be complaining if someone says, hey, here's an extra $5,000, and get an extra nice suit for prom. But now the question becomes, well, you want to retire at age 60, and you want to have $2 million. It costs a lot to retire these days. It's not that much of an exaggeration to think that you might need $2 million to retire. It depends how many kids you have and how you and your family want to live, but you might need more or maybe slightly less than that. But let's just assume that you want to retire at age 60 and you want to end up with $2 million. The question is, how much will you need to save each year? So if you think about what is it that the question is asking you to find, it's how much you need to save each year. Where does that come into play? That's this 500. How much do I need to save each year? That is the initial term. So if you're thinking about this here, you want to be solving for this value here. You know that you're going to accrue 4% interest every year, but you're trying to figure out what does that value need to be. Well, you retire at age 60, so how many years are you going to be saving for? Well, let's just assume that you're 18, so you're going to save for the next 42 years. And you know that when you're all said and done, you want this value to be $2 million. So let's put it all together. You're going to be saving for 42 years. So just think about that. How many terms are you going to have? Here you save for 20 years. Here you're saving for 42 years, and each year you're depositing 500 in. So at the very start, you'll deposit some amount of money, and then each year for 42 years, you're going to deposit another sum of money, and it's going to collect interest. So you're going to have 43 different terms, all the way up until the very last one, which is just going to be that last deposit that you make. So what you're doing is you're computing S sub 43, the partial sum up to 43 terms, where your initial value is something you don't know. Let's call it X. Some value you don't know. Accruing 4% for 43 years, or 42 years, which means I'm raising it to the 43rd power, minus 1, divided by 1.04 minus 1. And what does this need to equal? Well, you want this to equal $2 million. So what you need to do now is go through and solve for X here. Now I went through and solved this out, and basically I'm just doing inverse operations. So the first thing is I'm going to multiply by the denominator. 1.04 minus 1 is 0.04. Then I'm going to need to divide by this 1.04 to the 43 minus 1 on both sides, so I'll do that. And to compute this, I just go ahead and type it into my calculator, and that's going to give me 18,180 as the initial value, which is what I need to be inputting to my bank account each year. So just take a second to think about what that means. If all you're going to do is put your money in this retirement account, where you're getting 4% each year, you're going to need to save $18,000 per year if that's all you're planning on doing. For 42 years, that's a lot of $18,000 to be saving. So that's why it's so important to plan for retirement at an early age, and to make sure that you have some investments that you think will be able to get you to where you want to go. It's kind of a scary world out there, but at least you know what you need to be doing. So here, what we are taking a look at is a situation where each day the amount of salt that I put in gets cut into thirds. So for example, when I put in 300, after the first day only 100 of it remains, meaning that I'm multiplying by 1/3. So if I take this all the way, I start with the first term, which is 300, and that's the very beginning. Then after the first day, there's 100, and if I keep moving all the way to the 20th, what I'm realizing is that I've had to multiply by 20 1/3. So it's 300 times 1/3 to the 20th. All right, this is actually the 21st term, but it's the amount after the 20th day. That's because at the beginning of the first day, I put in 300 grams of salt, and that's a very, very small amount of salt. It's 0.00008 grams of salt. Okay, so very, very little, right? But that's only for the first batch of salt, and so I'd actually like to think about how much will be in the tub after 20 days, because each day I'm putting in another 300 grams of salt. And so this can be solved in the same way that I did the last, that we solved the last question, where we think about each 300 grams of salt and how much of it will be left over. So the first one is going to be 300 times 1/3 to the 20th. The next one is going to be 300 times 1/3 to the 19th. And this is going to continue all the way out until I have 300, right? The amount that I dump in at the very end. And this is nothing more than a partial sum of the first 21 terms, where the initial value is 300 and my common ratio is 1/3. So to solve this, it'll be 300 times 1/3 to the 21st power minus 1, all divided by 1/3 minus 1. And you can imagine that you'll get some sort of positive number. And I want you to think about, what will this number be about? Could it be less than 300? No, it can't, because I'm adding 300 at the very end. Can it be, like 10,000? Well, probably not, because each of the other 300s is being cut into thirds a certain number of times, and so that's, as we saw here, this is a very small number, this is also a very small number. It's probably not going to be a whole lot bigger than 300, right? Not that much, maybe 500, 600. So you should be looking for a number about there. And it turns out that's what you get. You get about 450 grams of salt. All right. Hope that went well. See you guys tomorrow.